Okay, so our last unit, we were simplifying trig expressions. Now, what we're going to do today is just do the same thing, but wouldn't it be nice if when I was simplifying, I told you what the answer was ahead of time? Well, that's what we're doing today. And these are going to be called verify trig identities. And these are actually out of section 5.2 in your book. So basically what we did on the last unit was I gave you things that look like this. We're going to take the cosine of theta times the tangent of theta, and we're going to simplify that. Well, what we do today differently is we say, okay, well, I'm going to go ahead and tell you that this should simplify to sine. And what you need to do for me is prove to me that the left side becomes the right side. We actually did a few of these back in your notes in section 4.3. You'll see that we did these, and I actually made you set these up as two-column proofs. Well, I'm not going to make you set these up as two-column proofs anymore. But what I do need you to understand is that this is, in fact, a proof. I'm trying to prove that usually the harder-looking side, the left-hand side, is somehow going to simplify and equal the right-hand side here. This is my goal. So when we do a proof, the first thing is we always recopy the given. So my given here is that I was given the cosine of theta times the tangent of theta. That is my given information. Now what I'm going to do is I'm going to use my identities. You guys should have that identity sheet in front of you. I'm going to use my identities to show that that simplifies into sine. So, like we did on the last unit, try to keep things in sine and cosine form. That's one general rule to follow. So I'm going to keep cosine where it is, although I am going to write it as a fraction. Now tangent, I'm going to change tangent using a quotient identity and say that tangent becomes the sine over the cosine. So now I can see that my cosines cancel, and when I cancel those and multiply across, I get the sine of theta. So it's the same thing we were doing, it's just now I'm telling you what the answer is. So I'm verifying that the cosine of theta times the tangent of theta became the sine of theta. And I'm done. So I actually think these are easier than to simplify because at least you know what your answer should be. So for question number 2, if I give you the sine of theta over the cosecant of theta, and I want to know that that's going to simplify to sine squared, I'm going to again do this as a proof, without actually doing it as a two-column proof. So I'm going to start with what appears to be the less simplified side, which I think is clearly this side, and I'm going to recopy that. So that is the sine of theta over the cosecant of theta. And I somehow need to prove that that becomes sine squared of theta. So here's one approach for this. I'm going to leave sine alone because I see that there's signs in my answer. But I'm going to change cosecant using a quotient identity, which would be 1 over the sine of theta. So I now have a fraction divided by a fraction. So if I take the top fraction, which is really sine theta over 1, divided by the bottom fraction, which is 1 over sine, I divide fractions by multiplying by the reciprocal. So this 1 over sine here, I'm going to flip over to be sine over 1. And now if I multiply those together, lo and behold, I get sine squared, which is what I was trying to get. So I am done with that problem. Question number 3, what if I give you something that looks like this? 1 plus the cosine of x times 1 minus the cosine of x, and that's going to equal sine squared of x. So, again, pick the side that looks more complicated, less simplified. I think for this one, that is clearly this side. So I'm going to recopy that side, 1 plus the cosine of x times 1 minus the cosine of x. Now I need to do something with that. Well, to me, that looks like something that can be multiplied together or FOILed out. And I can see that they're conjugates of one another. So if I FOIL all that out, I'm going to wind up with 1 minus cosine squared. Well, 1 minus cosine squared is where I'm at. Look at where I'm trying to get to. I'm trying to get to sine squared x. So now this is where I have to get creative with my identities and say, well, how can I go from 1 minus cosine squared to sine squared? Remember, Pythagorean identity, I know that sine squared plus cosine squared equals 1. So I need to be able to look at that and say, oh, well, if I move the cosine squared over, then sine squared is equal to 1 minus cosine squared. So 1 minus cosine squared can be replaced with sine squared, so I come back over here and I say, oh, 1 minus sine squared, 1 minus cosine squared is sine squared, and I'm done. I got my answer. Let's try one more. Question number 4. Cosine theta times secant theta minus cosine theta equals sine squared theta. So again, pick your side that's more complicated. I think that's clearly this side. We're going to recopy cosine theta times secant theta minus cosine theta. And now I'm going to simplify this. So what can I do? Well, I think I can distribute here. Let's try that. So if I distribute the cosine through, that gives me cosine theta secant theta minus cosine squared theta. Okay, I need to somehow prove that that becomes sine squared. Well, let's focus on this portion of it. Can I do anything to simplify that? Well, I'm going to keep cosine where it is, but I have a quotient identity that allows me to replace secant with 1 over the cosine. I'm not going to do anything with this cosine squared. I'm just going to let that hang around. Now, I think you guys can see here that those are going to cancel. And if I cancel those, everything canceled there. That just leaves me 1 for this whole piece minus cosine squared, and then we just did that in the last problem. 1 minus cosine squared using a Pythagorean identity can become sine squared. Okay, so this is kind of weird stuff. You guys really haven't done math like this. Just do the best you can with this. Look at my answers that I have posted. See if you can follow what I'm doing. You know, this isn't the best scenario to be able to teach this stuff this way. But it is what it is. So see if you can follow what I'm doing, and if not, catch me on email or Zoom. I'll talk to you guys later.